Hey ho cheerio all of you specks of stardust. A thing. I'm sorry, but I need only one thing. A thing. Only a handful of flat earthers seem to be able to understand, from what I get. It's what globe dopes like me mean when we talk about degrees per hour and what this has to do with speed. As a matter of fact, the surface velocity of the surface of Earth is 1000 miles per hour, but only at the equator. And this is the problem. As you wander off the equator, closer to the poles, the speed reduces until you are in the middle of Antarctica or Arctica. There you have 0 miles per hour. But the globe is still spinning. So, the speed of the surface is something that is not consistent in quotation marks. It strongly depends on where you are on the globe. But, the thing that stays the same, no matter where you are on the globe, is the rotation progress in a certain time. Degrees per hour. No matter where on the globe you are, no matter how big the globe/ball is. As a side note, yes I am talking to you, you tennis and basketball wetters out there. It is beyond me how in the slightest doing this makes even remotely any sense to you. That aside, you need to know that 360 degrees make one full rotation. 360 degrees are 100%. Then you just need to know, look up on the internet, do the same as Eratosthenes to get the circumference of Earth. Google, provide me with wisdom. And then you can start calculating all the speeds, accelerations, and forces you want to know. Let me show you. The first thing to do is to set a goal. I want to know how fast Earth is spinning at, let's say 45 degrees from the equator. But before that, let me quickly calculate the radius of Earth. I know I will need it. Let's see if 1000 miles per hour are 15 degrees per hour. Looks like I got it right. Nice. As next we need to know the circumference at the 45 degree point I marked. We know that the red line at the 45 degree mark is for simplicity the same length as at the equator. Now we can also double the line so that it's shown on the other side too. With that we get a symmetric triangle with two equally long sides. Since it is a 45 degree angle, the angle between the two 45 degree sides is bound to be a 90 degree angle. Which lets us use the easy version of Pythagoras law in which we don't have to remember where we have to use cosinus, sinus, or God behold tangent. After we pro-square the radiuses and play our polymerization spell card, we can unsquare the resulting tangential abomination of a number to get the hypotenuse. Then we just need to half that sucker to get our new radius. Now let's get the circumference. Retrospectively, halving the value was pretty pointless. Okay, now that we have the circumference, we can get to know how much slower the surface speed is at this point of Earth. Since we know that it are 15 degrees per hour, we can take the time factor and attach it to our distance result to get a surface speed. Now we can see that there is roughly a 500 km per hour difference between the 2 points on Earth. And that's the reason for the Coriolis effect. Different points on Earth, different surface speeds, but same angular speed. Now we can be so funny and turn those two speed values into accelerations. But first we need to turn the one new speed into meters per second, or we get a confusing and wrong mess. Because it is easier, and also because meters and seconds are SI units. Now that we have it in meter per second, we need to think of what an acceleration is. Like speed is way over time, so is an acceleration speed over time. To say it in other words, if you accelerate with x meters per second, then this means that you add your speed x to your total speed every second, or short, meters per second. But we can't just take our two speeds here and just divide them with an additional 1 second. To do that is unfortunately wrong. It just has to be a bit more complex than that. So what we have to do is to let the speeds do the square dance and then divide d/z with their corresponding radii. And this time I did it correctly and not like in my shit post of a Coriolis video. And to fix old sins, let's put it again into contrast with the gravitational acceleration near Earth's surface of 9,81 meter per square second. Yeah, this time the relation number is by a factor of 10 bigger, ensuring once more that there will never anything be slung off of Earth's surface because of the rotation. The last thing we can do is to turn the accelerations into forces. Let's say 80 kilograms. Now we need to multiply that to the accelerations and voila, forces. As you can hopefully see, it's no magic that we don't get a free flight into space, and that water is allowed to stick to the globe, and the atmosphere too. Actually everything. I hope it was interesting, and I hope I didn't build in errors again. Before the video ends, there is another thing to say. If you are a flat earther and you are using this formula to calculate a drop in the distance for the globe, please just stop. There is no good coming out of it. A parabola is not a circle, and will never be a circle. Please just take 2 times radius times pi, and some rule of 3, and do the Pythagoras. A square plus b square equals c square. Well then, bye bye.